So our topic is heating effects of electric current. But before going ahead, let us understand its definition, why it is forming and in what cases it is producing, right? So whenever electric current is passed through a conductor, we have seen that जब भी हम current start करते हैं, it means whenever we are using some appliance, it gets hot after some time. इसका ये मतलब हुआ कि जो हमारा इलेक्ट्रिकल एनर्जी है is getting converted to heat energy. This is called Joule heating and it was observed by James Prescott Joule. What is happening inside the conductor? Let's see. First case is that if the number of currents flowing through the conductor per second increases, then the heat energy also increases. What does that mean? The number of electrons or charges flowing through the conductor per second. This is nothing but the definition of current. If the current flow in the conductor increases, यानी कि ज़्यादा electrons flow हो रहे हैं इस conductor में, ज़्यादा electrons flow होंगे तो they go under more collisions and due to collisions their energy, electrical energy is converted to heat energy. So collision बढ़ रहे हैं इसकी वजह से heat बढ़ रहा है. Same goes if the resistance of the material is increased. मतलब अगर material का resistance ही ज़्यादा है, again it will give rise to collisions. ज़्यादा collisions होंगे फिर से, and again there will be more heat energy. And the third factor on which the heat energy is dependent is the time duration. कितने टाइम के लिए हमारा सप्लाई चालू है. जितना सप्लाई ज्यादा होगा, ज्यादा देर तक चलेगा, उतना हीट ज्यादा प्रोड्यूस होगा. Why? Because for the duration of time for which the conductor is running, जिसके अंदर इलेक्ट्रॉन्स चल रहे हैं, फ्लो हो रहे हैं, यानी करंट ज्यादा टाइम तक फ्लो हो रहा है, मतलब उतने टाइम तक कोलिशंस चलते रहेंगे. And that is how time is also a factor on which heat is dependent, right? So based on this, he gave a formula as H is equal to I square RT. How it is derived, we will do it in a second. We will find it mathematically what he has done, right? For this, for an electron to go from point A to point B, work done is done, and electric potential difference is defined as work done to bring a charge, यानी कि Q, from point A or one point to another point in the field is defined as electric potential difference. I can write it in terms of work done as V into Q. I'm stopping here and giving it number 1, this equation. Let's go ahead. We have studied the equation of current. I is equal to Q upon T. So I can say Q is equal to I into T. I'm giving this as 2. Also by Ohm's law, we have studied that V is equal to I into R. Right? So I'm giving it as 3. Now by using 1, 2 and 3, I can say work done. Instead of this V, I am using IR, and instead of this Q, I am using IT. So this gives my formula work done is equal to I square RT. यही जो वर्क डन हो रहा है एक चार्ज को कंडक्टर के एक पॉइंट से दूसरे पॉइंट में लाने के लिए बिटवीन द पोटेंशियल डिफरेंस V, वो वर्क डन इज कन्वर्टेड इन द फॉर्म ऑफ हीट, and this work done is then referred to as Joule heat. H is equal to I square RT, and its unit is Joule because it's a unit of energy, and it's known as Joule heat. So some part of our supply, जो भी हम सप्लाई दे रहे हैं, उसका थोड़ा सा पार्ट वेस्ट हो रहा है in terms of heat energy. So we have to think कि हर बार ये जो वेस्टेज है, क्या हम उसे पॉजिटिवली यूज कर सकते हैं? Can we apply this loss in our favor? Right? So there are some things which you are using it on a daily basis. I will start with an example of a electric iron it is used to press our clothes, right? So वहाँ हम deliberately we are heating the surface of the iron so that we can use it to our advantage, right? So this is an application of electric heating, right? Another is electric kettle, another is fuse wire, and another is, we can say, microwave oven. And some of them you have to think, you can write it in the comments, whichever comes to your mind, think about it कि कहाँ कहाँ हम heating due to electrical appliance अपने advantage में use कर सकते हैं. You can write it in the comments and let us know. And this is a very frequently asked question, where applications of Joule heating. So think upon it and do tell me what are your views on that.